Hello, everybody, and welcome to the webinar today. My name is Patrick O'Brien, and this webinar will be looking at the defining incidents in industrial cybersecurity. If we think about the last 20 years, industrial cybersecurity really has changed quite significantly. Um, Originally the question may have been who would possibly want to target an industrial control system. There is really a limited awareness of what value those targets may have to attackers in the early days, and security systems weren't really in place or even thought about for industrial systems. If we fast forward to today, the more likely question is probably, which industrial facility will be affected next, because we've seen so many different high-profile incidents and just quite a lot of compromises that have happened for industrial control systems. And so what we'll be doing today is really walking through the timeline and looking at the major cybersecurity incidents for industrial systems, such as Stuxnet, the Sadara Petrochemical Facility, NotPetya, and the German steel mill, and really think about what have these events taught us about industrial cybersecurity and how have they really shaped the industry. My name is Patrick O'Brien, and I am a safety and cybersecurity engineer at exida. I've worked at exida for a little over 5 years now with a background in chemical engineering. So I started out really more on the process and functional safety side. And over time, we really started to see that cybersecurity was having a key piece and a growing role in the ability of plants to achieve their safety goals. And so there was kind of a natural transition where I started to look at both safety and cybersecurity concerns. Before jumping into the content of the webinar, I just want to do a real quick background on exida. We are a customer-focused company, and we really work globally with our customers in 3 main areas. The first area is our enterprise tools. And for the end user side, that really deals with Excellentia, and we have modules for not only functional safety activities, but also cybersecurity and alarm management as well. Our certification and assessment group works with original equipment manufacturers to go through and do certifications for equipment to functional safety standards such as IACS 61508 and IACS 61511, as well as machine safety and cybersecurity standards. And then for our lifecycle services, we work directly with facilities, plants, and end users and help them to really tackle their toughest problems for the cybersecurity, functional safety, and alarm management life cycles. And that's really where I predominantly work. Throughout this webinar today, we will look at 3 main pieces, starting with cybersecurity incidents and really walking through chronologically what are some of the major incidents that have affected industrial systems. From there, we'll look at pulling together some of the key incident trends and key takeaways from these incidents before looking at what are practical steps to improve cybersecurity defenses and really help industrial systems be better protected from future attacks. And so we should have about 10 minutes at the end of the webinar to go through any questions. And so as we're going through the material, if you do have any questions, don't hesitate to use the question tool in the GoToWebinar application. So to get started and really go through these incidents, we'll walk through them in a chronological order. And the first one actually dates all the way back to 2000 when a wastewater treatment facility in the Maroochy Shire, a small city in Queensland, Australia, was compromised. And so it was found that a former employee from the third-party contractor, so the group responsible for integrating and working on the control system, he had, had a disagreement, had a falling out, and had resigned from the integrator, and then tried unsuccessfully twice to get hired by the wastewater plant. And so as a result of this, by being denied employment, he then went ahead and initiated the attack. Um, to do this, he stole a laptop, a remote terminal unit, or essentially what was used to remotely connect into the SCADA system for the wastewater, and also a two-way radio. And so with that, with the technology that he grabbed, he was basically able to, whenever he was within range of the pumping stations, log in and begin remotely altering the configuration and causing a number of different issues. And so throughout the number of different attacks, there were some smaller issues in releases. Ultimately, the worst incident happened when 264,000 gallons of raw sewage were released into the Maroochy River and the surrounding area, impacting local wildlife, the community, and a number of businesses in that area. As a result of that, there was over $150,000 spent by the community on cleanup, and additionally, the total costs for the contractor were over $500,000. And so this attack was notable for a number of reasons, um, not the least of which being that it really is the earliest, the first confirmed cybersecurity attack on an industrial system. And so even though it was a very early attack, it highlighted a couple of different things. The first was that the attackers not only were able to modify controls and set points, but they actually were also able to disable alarms and really prevent the operators of the system from understanding what was going on, and really took steps to hide their tracks. It also is notable because it is still one of the clearest examples of a negative environmental impact resulting from a cyber attack, really having a massive impact on that localized area. What was interesting, and really what there was a potential for much more significant harm to be caused in the attack. And the chief executive for the integrator basically mentioned that had the disgruntled employee, intended to go after the drinking water to, disrupt any of the, filtering or, chlorination process, he would have faced virtually no obstacles in doing so, and could have really created a major consumer health issue in the area. And so this was important to realize and highlight just how ineffective security measures were for automation systems. Really at the time, no security features were commonly used or adopted by automation control systems. If we fast forward to the later 2000s, 2008 to 2010, we can look at the Stuxnet virus, or really the attack on an Iranian nuclear facility. And if you talk to experts for industrial control system security and ask them to kind of pick the one defining event, this really is that flagship event where the need for industrial cybersecurity was introduced at the world stage, and really highlighted some of the common failings. And so the attack looks to have been developed potentially as early as 2005. The development began because this was really a sophisticated, what went on to be known as a digitalized weapon for targeting the facility. Although it hasn't been officially attributed, it is widely believed that the attack was developed primarily by the United States and Israel, with support from a number of other friendly nations and allies. And so the attack was specifically targeted for the Natanz uranium enrichment facility in Iran. And look to cause damage to centrifuges and really cause major operational issues. And so from an impact standpoint, the malware infected over hundreds of thousands of computers and ultimately caused 1/5 of Iran's nuclear centrifuges to physically degrade. There were a number of different versions of the Stuxnet virus that worked in a few different ways, but one of the earliest versions essentially worked by manually closing the valves at the inlet and outlet of some of the different centrifuges to disrupt the normal flow, to increase flow through certain centrifuges, to really increase the pressure and cause damage that way, as well as to disrupt and reduce the amount of refined uranium that was received from the system. And so by doing this, the attackers were very careful to avoid detection. They took steps of what's called a man-in-the-middle attack, where they were actually feeding back incorrect process data to the human-machine interfaces to prevent the operators from seeing what was actually happening in the system. And so what the program would do is it would first take a normal pressure reading of the centrifuge before closing any valves or manipulating any set points and feed that back to the operators. And then from there, for up to 90 minutes, it would manipulate the centrifuges and cause that damage. Once the time had elapsed or a significant enough pressure was detected, the virus would then return the valves to the normal condition, to their normal positions in order to avoid detection. And so as a result of this, the attack went widely undiscovered for 2 years, caused significant damage to more than 1,000 centrifuges, and really was a significant setback on the Iranian nuclear development ambitions. One thing that's interesting to look at in the attack is to really understand how the attack was first introduced. The facility was intended to be fully air-gapped from any internet-connected systems, and so they needed a method for really introducing the virus. And so the easiest method to do that was through the use of USBs or flash drives that contained the malware file. Um, and so it's believed originally the thought was that the attackers may had left the USBs in the parking lot of contractors and that the first USB was accidentally plugged in out of curiosity. Later reports actually suggested that the Dutch intelligence agency was actually able to compromise an employee at one of the contractors and was able to use them as an insider to first deploy the attack. Regardless of the initial introduction point, it is known that future versions of the virus were spread unknowingly through compromised machines based on this USB. And there were a number of zero-day vulnerabilities or vulnerabilities that were not previously known about that were used in developing the attack, one of which related to the signatures and how the software for the virus appeared and was able to avoid detection on the system. And so really, Stuxnet had a major impact and really a long-lasting legacy when shaping industrial cybersecurity. It's been known as the world's first digital weapon, and really the first example of cyber warfare or nations engaging in cyber activities to attempt to alter the course or shift a nation's production plans and really take that as a step to get an advantage. Um, it also provided a clear roadmap for future sophisticated attacks on industrial systems, and the source code is now widely available. And not just that, but it really was a proof of concept to show what a cyber attack could do to an industrial system and really how significant that impact could be. With that, it also slowly really started to highlight the need for industrial cybersecurity and really was one of those main catalysts in the industry growing and becoming what it is today. And many of the standards that were developed around cybersecurity really started to gain traction around this time. The next attack that we can look at is the attack on an unnamed German steel mill. This took place in 2014, and although not many details about the victim have been released, we do have a good understanding of the pathways and the methods used in the attack. And so the attackers first gained access to the corporate or IT network, and they did this through targeted emails that appeared to come from a trusted source. This is also known as phishing, where basically the attackers are trying to trick users into either clicking on a link and downloading malware, or entering in their user credentials to compromise those accounts. And so in this case, the emails included attachments that downloaded malware onto the corporate PCs. From there, the attackers made a transition from the IT to the OT or the automation network, and were able to establish a VPN that they could use for remote modification of the control settings. And so the result of this was that the attackers were able to either fail individual control elements or the entire control system, which ultimately prevented a blast furnace from being shut down safely, and resulted in what was described as massive damage to the site. Now, the German steel mill attack is important because it really was only the second confirmed attack that resulted in physical damage from a cyber source. And although the attack did result in significant equipment damage, it could have very easily resulted in a safety impact if any personnel had been in the area of the blast furnace when the damage occurred. And there have been a number of industry events with blast furnaces that have resulted in not only serious injury, but also fatalities. It also showed really how easy it was for attackers to gain access to a corporate network through phishing attempts, as well as then the ability of attackers to move within a system and make the jump from the IT to the OT network, and use that as really a common pathway to compromising and manipulating industrial systems. The next attack that is important to look at is an attack on the Ukrainian power grid. And so the Ukrainian power grid was actually targeted in a number of attacks, but the first one occurred in 2015. In this attack, Ukraine's power grid was shut down, affecting over 200,000 customers for between 1 and 6 hours, depending on the area. And so what happened here was attackers were able to gain access to, again, the corporate network for the grid through a targeted phishing campaign that was in this case targeted at the IT and system administrators. And so whenever those Word docs were downloaded, the virus was able to gain a foothold on the system. Once being connected to the corporate network, the attackers were able to harvest and collect remote login data and use that to compromise the SCADA network by using a VPN, so establishing that remote access. And from there, they had the ability to manually shut off breakers, as well as they took steps to overwrite the firmware for gateways and other critical devices, that really then led to a lasting impact on the system, where even once the attackers had been prevented from gaining access to the system again, those breakers had to be controlled manually because the control system couldn't be restored. And so although attribution of attacks is often up to some debate, it is really relatively widely believed that both the first and second attacks on the Ukrainian power grid were likely done by a nation-state actor supported by Russia due to the tensions between the Ukraine and Russia. In the second attack on the Ukrainian power grid, this one occurred in 2016, and the strategy was quite a bit different. This malware is described often as either crash override or in destroyer, and it was different in that it didn't require the same level of manual intervention to initiate and trigger the power outage. Um, it had the logic function of a logic bomb, or essentially it was configured to go off at a predefined time. And with that setting, it could be installed on as many systems as the attackers were able to get um, access to, and then triggered simultaneously to really affect all of them at the same time. And so this greatly improved the scalability of the attack and introduced the ominous potential to attack multiple systems at the same time, and really cause more of a widespread rolling blackout. Additionally, investigation into the malware indicated that there was functionality with the potential to communicate directly with protective relays for the transformers. And so what this meant is, had attackers configured the malware to basically disable and prevent those relays from working, it could have led to physical damage of the transformers, and potentially even some safety issues as well due to the high voltages. And so again, had the attackers used this functionality to its full potential, they could have caused significant equipment damage and increased the time taken to recover from the outage. If we think about then what are some of the key outcomes from the Ukrainian power grid, um, there are a couple major takeaways. The first is that these attacks showed how vulnerable the power grids were to cyber attack, and how easily attackers could cause significant blackouts or disruptions to critical infrastructure. As a result of this, a number of countries have actually taken the approach of implementing retro technologies for the grid, and moving away from digital systems to more manual-based systems that require greater operator intervention, but are inherently less susceptible to cybersecurity attacks. And so there have been a number of steps taken in the US as well as in other countries, really to step back from a highly automated power grid. Uh, Additionally, this was another attack that demonstrated the potential for cybersecurity actions to not only affect organizations, but to also disrupt consumers as well. The next attack that we'll look at, NotPetya, um, also is believed to be led by a nation state associated with Russia, and was targeted against a Ukrainian company called Linkos Group in 2017. This attack was a wiper worm, or essentially something that was designed to propagate automatically, and destroy the files and critical information on any device that was compromised by it. The attack was initially introduced from the Linkos Group update server, where the attackers had implemented a backdoor that would automatically download the worm onto any victims that access the site. And so this functionality in an attack is often known as a drive-by or watering hole attack, because it puts the virus in a centralized location and then is able to affect anyone that goes to the watering hole, or even if they're just passing by the website. If they click that link, that is the or if they go to the website, that's really the only action required to download the worm in this case. And so what was found was not only did the wiper worm impact the Linkos group, um, but it rapidly spread because it used a combination of two different exploits. The first exploit, Eternal Blue, exploited a known vulnerability and allowed malware to automatically replicate and quickly spread throughout networks. Um, Now, this was a known vulnerability in the Windows operating systems, and at the time of the attack, there was a security patch available that could prevent the Eternal Blue functionality from being successful. What was found, though, was that the NotPetya attack also leveraged Mimikatz, or a functionality to extract passwords that were stored in memory. And so the result of putting these two pieces together was that if there were any uh, computers on a network that had not been patched against Eternal Blue and the virus was able to gain that foothold, by extracting passwords, the virus was able to make the jump to patch systems as well, because it now had those credentials. And so because of that, the attack really spread rapidly worldwide. At the time, Tim Bossert, who worked for the Department of Homeland Security, described the NotPetya attack as the equivalent of using a nuclear bomb to achieve a small tactical victory, in that meaning that it caused significant damage and rapidly spread, affecting more than just the target, really for something that was originally intended to have a relatively small impact. And so countries all over the globe were infected by the virus, including a number of sites in Russia. When we look at the NotPetya attack and the ultimate cost, it is expected and estimated that the attack resulted in $10 billion of damage um, throughout all of the different companies that had been affected. And there were quite a few companies with industrial automation systems that were severely impacted by the attack. Um, the pharmaceutical company Merck um, had an estimated cost of over 870 million resulting from the cybersecurity attack. Um, FedEx and the subsidiary TNT Express experienced a significant impact from the delivery side. Companies in construction, shipping, food and beverage, and even consumer goods all saw very significant impacts and costs greater than $100 million. And so from these companies that were hit quite severely, as well as other companies that had less severe estimated costs, it's expected that the attack ultimately costs over $10 billion. And so with that, there really was a profound lasting impact of NotPetya. It showed, firstly, that attacks are not always as targeted as they may originally appear to be, or they may not only be designed to go after a specific target. If we think back to the Stuxnet virus, very special care and attention was taken when developing that virus to make sure it only affected the specific controllers in the specific system, and that if it had been installed on any other computer network that didn't meet that criteria, that it would be harmless and not cause damage. For this case, we saw that when those steps aren't taken, it's very easily for a program to really rapidly spread and cause significant damage. Because of that, it's likely the most financially damaging cyber attack of all time, with that $10 billion price tag. Um, Additionally, it highlighted that sophisticated attacks are not just a concern for, say, large sites or things that may be specifically targeted, but really any company with interconnectivity could potentially be exposed to these types of attacks and see the associated consequence. Additionally, it really highlighted that many companies had poor perimeter defenses which showed why it was so easy for the program to quickly spread. The next attack that we're going to look at took place in the Middle East at the Sadara Petrochemical Facility. It was a series of attacks ranging from November of 2016 up until August 2017, and it resulted in an unexpected shutdown of the process. Now, originally it was believed that this was a second round of the Shamoon attack, or a previous malware attack that had resulted in a shutdown and the destruction of data for a number of industrial companies in the Middle East region. But as researchers really learned more about the code and took a closer look, um, they actually discovered that it was most likely intended to trigger a deadly explosion. Um, and with that, the attack had successfully overcome a physical lock and key system that was used to protect the safety controller from being updated during the run mode. It was determined that a bug in the attacker code was what resulted in the plant being shut down before an ultimate consequence. And as further research was done, they actually were able to really pinpoint what had happened. And so they found that the DMZ and BPCS systems had been successfully compromised. And so the attackers had the opportunity and really the choice to modify and change controller set points on the control side of things. But they didn't stop there, and actually intended to move on and target the safety system as well. Um, and so the original philosophy for the facility was to have an air-gapped or a separated SIS engineering workstation and network that was not connected to the rest of the plant. But it was found that there was actually an accidental connection from the DMZ to the SIS network, and attackers were able to use that to gain remote access to the network. Um, from there, they were able to overcome the locking functionality and modify the set points for one of the safety controllers. Uh, but because it was a redundant safety configuration, one of the safety PLCs still had the correct functionality. And so the comparison check between the two controllers identified that something was wrong, that the configurations didn't agree. And because of that, a safe process shutdown was triggered. Had the attackers been successful in compromising both safety PLCs, it's very likely that they may have been able to successfully trigger an initiating event and disable the safety protections for that hazard. So whether it is, a runaway reaction type event or overpressuring a vessel, it's likely that they may have been able to trigger that explosion scenario. And so this was really a groundbreaking attack for a number of reasons. Um, the most prevalent is that it was really the first confirmed attack that had the sole intent, or really the focus, of triggering a health and safety consequence. That was really the objective that the attackers were trying to achieve. And it was one of the first attacks that really specifically targeted and went after safety instrumented systems in order to achieve that functionality. In the past, attacks like Stuxnet and the steel mill, they had overcome protection layers, but those were really more, say, safety critical controls that were still tied into the control system, not a separate safety instrumented system. It also highlighted that there's no such thing as a completely effective countermeasure or something that is non-susceptible to cybersecurity attack. If it is connected, there does exist that potential. And so even though the Triconix controllers had a remote key to switch between run and configure modes, and they were in the run mode, um, the attackers were, because of that connection to the DMZ, they were able to establish that access and then leverage a zero-day vulnerability in the program to be able to make modifications even while it was in run mode. And so because of that, it really showed what potential attacks could do to cause harm. It was another example where it was believed to be a nation state actor, in this case, most likely supported from Iran, to really try to shape the political situation in Saudi Arabia, where there were ongoing efforts to um, actually privatize or yeah, move public parts of the um, industrial and oil capabilities, really to have a major financial impact. And so it was believed that this attack was really meant to hamper that effort. The last attack that we will look at is an attack that happened just in 2020 on a German hospital. And so in this incident, ransomware infected the Dusseldorf University Hospital last September. And as a result of the ransomware, the hospital computer systems were disabled and they were unable to carry out certain treatments. Um, it was known that the attackers leveraged a vulnerability in the Citrix VPN to establish remote access to the hospital system. And so during this attack, a female patient died while being transferred to another hospital in the area to undergo treatment. And so, if confirmed, this really would have been the first direct fatality resulting from a cyber attack. And the authorities in Germany opened a negligent homicide investigation to look into and review the hacking incident. Um, Now, what was interesting about this attack was that the hackers actually provided the decryption key to the hospital before demanding any payment. And because of this, many believe that the hospital actually was not the originally intended target for the attack. Um, Additionally, in the investigation, um, it was ultimately determined that the patient's medical condition was the sole cause of death and that it was not directly linked to the cybersecurity attack. Now, although in this case, the attack did not result in the health issue um, or the loss of life. Many health experts and cybersecurity experts familiar with the incident and who are involved in the investigation really do believe that it's only a matter of time until a similar cyber attack does result directly in such a tragedy. And so there were a lot of important lessons to be learned from the attack on the hospital. The first is that many hospital and health systems are very poorly defended from cybersecurity attack. Similar to industrial automation systems, there is a lot of legacy equipment that may not be able to be patched from certain known vulnerabilities. Also, it was another example of attacks potentially impacting sites other than the original target, and really showing that based on that interconnectivity, even if you're not a prime target, there still is absolutely that potential for negative impacts. And so really, um, it also showed that ransomware, although it is typically thought of being a financial impact, when it does affect critical systems, has the potential to result in much more severe consequences as well, and that potential for a serious patient health issue due to cyber attacks and cyber incidents still remains. And so if we look at these attacks and think about, what are some of the key trends to pull away, um, probably the three biggest takeaways are that attacks can come from many different sources, attacks can affect many risk receptors, and that control systems are severely vulnerable to attack. Um, if we think about the threat sources, we've seen these major incidents be triggered by many different nation states or advanced persistent threats, so groups with really sophisticated resources and skills. Um, We've also seen a number of different skilled attackers, such as cyber criminals or those looking for monetary gain, who have had impacts on automation systems. A growing trend and something that is really increasing the number of potential people that could really cause harm to industrial control systems is the rise in unskilled attackers, sometimes referred to as script kiddies, or basically thinking about an untrained group that, because of the growing access to hacking tools and really readily available ransomware kits and other types of malicious software, that people with relatively low skill can be very successful at now causing cybersecurity incidents. And then lastly, it's important to consider also the impact of internal threat sources, whether they are disgruntled employees or the potential to introduce accidental cybersecurity incidents to a system. And those can be major causes of cyber incidents as well. The next piece is we need to, when we think about cyber risk for automation systems, we need to consider all of the potential risk receptors, and it's not just a financial issue. We've seen a number of attacks that have clearly not only been targeted at causing safety issues, but also may have resulted in them as unintended side effects as well. So thinking about not just personnel safety for the site, but the potential to cause product safety or consumer health warnings, as well as to affect access to critical infrastructure and healthcare services. We've also seen that cybersecurity attacks can have negative environmental impacts, such as the Maroochy Shire incident, or the potential for a chemical release to really have a significant impact on the surrounding environment. On the financial side, there are really a number of different ways in which cyber attacks can have really a negative impact, such as unexpected downtime and lost production, equipment damage, as was seen in the Stuxnet and German steel mill attacks, or even the loss of intellectual property and the associated monetary costs with losing that competitive advantage. That is another important thing to look at and consider for some of these data theft incidents. Cybersecurity can also have impacts in a number of, say, less tangible risk receptors by causing things such as loss of privacy or significant damage to company image or reputation. And so it's very important that those effects are considered as well. Lastly, when we think about the exposure of the control systems, it's not just the number of agents able to cause attacks that are growing, but really the overall footprint and exposure of control systems as well. A couple statistics from recent study that really highlight this are from one study that showed around 70% of all industrial control and automation systems now require some type of remote access. And so if we think about it, if plant personnel are able to establish correct access remotely, if they are able to establish that remote connection, there's the potential that attackers can establish an unauthorized remote connection as well. Another study found that 90% of organizations with operational technology systems had experienced a damaging cyber attack or an attack that had had some sort of financial or measurable consequence in the past 2 years. And so really it highlights that the vast majority of organizations really have had this experience, have identified cybersecurity attacks resulting in consequence. Additionally, we can think about the number of known vulnerabilities and the different components of the control system that need to be considered. Remote access protocols for any of those sites with remote access, operating systems, applications that are being run, and even the software on the embedded devices in the system. It's not just the Windows computers that need to be patched and secured, but also proprietary technology for control systems as well. And something that is, particularly difficult with automation systems is that end of life systems can no longer be protected, and that there is a wide legacy install base for automation systems that can be difficult to upgrade and quickly change. I know that when I've been on sites, I've seen systems all the way back to Windows 96 that are still running, because there are specific proprietary components on the system that haven't been upgraded and can only interface with that Windows system. And so these systems have many known vulnerabilities that the site doesn't even have the potential to patch or protect against. And so lastly, we'll quickly look at what are some actionable steps that can be taken to really improve the cybersecurity for industrial sites. And so we'll talk through training and awareness, physical security, the importance of personnel and account security, steps for network segmentation, and then really how this builds a defense in depth approach. And so the first step in any cybersecurity program needs to be training and awareness. The human element for automation systems is so important, and they are really continuing to be kind of a weak point in the cybersecurity defense. When we think about accidental errors introducing cybersecurity attacks, um, such as unintended connections between the DMZ and safety system, we could think about cyber hygiene issues and those personnel that are clicking onto phishing emails. Really, these are can only be addressed and looked at through improved training and awareness. Um, Additionally, if we think about physical security, whatever cybersecurity precautions we take, if someone can walk up and plug in a flash drive, we really haven't achieved our security objectives. And so having preventative measures such as security perimeters, locked doors, locked cabinets, or even port blocking is really important. But also having physical security detection such as motion detectors or video cameras can help give personnel an opportunity to respond and prevent physical security breaches. On the personnel and account security side, from a personnel security standpoint, it really comes down to having those background checks and following the HR policies and procedures to limit the likelihood of getting that disgruntled employee or having a compromised individual with access to the site. From the account security standpoint, we can think about following the principle of least privilege. So really making sure that personnel only have access to the parts of the system that they need and that they're really given the minimum access to do their jobs. Removing old accounts, making sure that for anyone with engineering or administrative access, that they do have their own unique access account with strong authentication methods, whether that is a strong password, two-factor authentication, really taking all of the steps possible to reduce the likelihood of an unauthorized connection. It's also important that both the personnel and account security activities are done not just for employees, but also for any contractors with access to the system. From the network segmentation side, having a strong defense strategy for segmenting the IT and the OT network. In many cases, it's best practice to establish a DMZ with two firewalls. There may also be the need for firewalls to separate the safety and control systems. Really taking these steps is important for achieving those security goals and doing regular audits and reviews of the firewall rules to make sure that they are in line with the requirements. And so what this builds overall is really that idea of defense in depth, that it's not any one step to protect against cyber compromise, but that we really need to build a layered approach through awareness, through all of those things that we looked at, to make it more difficult for attackers to gain access. There's no one layer that if we implement it, there's no potential of compromise. But by taking the important first steps, by really building up those defensive capabilities, we can make it much more difficult for threat agents to gain access to the control system. And so in summary, in this presentation, we looked at major cybersecurity incidents ranging from the Maroochy Shire attack in 2000 all the way through to the attack on the German hospital in 2020. We looked at major trends and what are some of the things that we can take away from these incidents. And then lastly, we looked at how can we take what we know about cybersecurity incidents and really use that to improve our cybersecurity defenses to really improve those security boundaries and make sure that we do have adequate protections in place. And so now I'm going to run through just a couple of our closing slides. If you do have any questions, don't hesitate to put them in the chat and we will go through those at the end. We have a number of upcoming online live training courses for the exida Academy. And so we have a great offering from functional safety to alarm management. And I will be leading a half-day CS 102 or automation cybersecurity lifecycle course coming up in mid-February. And now if you found the material of this webinar interesting and really want to learn more and kind of get more of the details on how to follow that defense in depth approach, how to assess cybersecurity risks, this is really a great training course to do that. We do also have a number of online self-paced training. And so this allows you to really go through and complete the training modules on your own schedule and make sure that you can do it in a time frame that fits for you. And so we do also have an option for the CS 102 course, which is a pre-recorded version of me walking through and giving the course. So that's a great option as well for anyone interested in learning more about cybersecurity. If you're interested on getting updates from exida on similar cybersecurity topics, please don't hesitate to follow us on all the latest social media. We're on Twitter, Facebook, and LinkedIn, and really can get updates on upcoming webinars and other news items that way. Also, if you have any questions that you don't get a chance to ask on the webinar, don't hesitate to send me an email or reach out on LinkedIn. I'm always happy to get questions, and we'll get back to you certainly on a quick time frame. So now let's pull out. Let's look at some of the questions that we've got. So let's see. One of the questions here is, how big of an impact do insider attacks versus outsider attacks have? And what's kind of the breakdown between intentional versus unintentional? And so one of the things that we've seen is that surprisingly, unintentional cybersecurity incidents still continue to have a major impact and effect on systems. And a recent study I saw said that it may still be as many as 80% of cybersecurity incidents are non-targeted or unintentional, meaning that they may result from a configuration error that allows a general malware or other, widely spread virus to gain access, or that they are some sort of insider error or configuration mistake that does result in an issue. And so because of that, really the training and awareness continues to be a major piece of this. Another question that we had here is, for the Sadara Petrochemical attack, it seems like having redundant safety PLCs was a key defensive mechanism or countermeasure for avoiding the attack. With the growing movement towards the use of single safety PLCs, what sort of impact does that have from a cybersecurity standpoint? And so you're right, we certainly did see that in the Sadara example, had they had a single safety controller, it may have been successfully compromised by the attackers and they wouldn't have had that safe shutdown, or really that realization that the compromise had occurred. Um, it's not to say that you can't use individual safety PLCs from a security standpoint. It all comes down to really the risk assessment and understanding how many protection layers are needed to really be properly defended from cyber incidents. And that's something that can be looked at really on a site-by-site basis. And so those are the two questions I see that have come in. Again, if you do have any other questions, don't hesitate to send me a message or an email, and I will be happy to get back to you. Uh, my name is Patrick O'Brien, and we have finished today's webinar. Please, thank you very much for your time, and have a great rest of your day.